Okay, so let's get started to the last session on the first day at Build. And I have to say, I'm fairly happy that the room is that packed. I didn't really expect that for a topic like hybrid cloud. We're going to have issues with the seats in the room. Primarily because when I did my rehearsal in front of my 2-month-old son, he fell asleep. So I'm going to do all and everything today that you don't fall asleep and to keep you up and running with what I think is a very, very interesting topic for cloud computing in general, and that's hybrid cloud. My name is Mario Spusta. I'm working as a program manager inside of a unit that is called Technical Evangelism and Development. In that unit, concretely in the global partner team, and we're working with global software vendors across the world to help them migrate their applications and solutions to our app platform, where we primarily focus on Windows Azure, or Microsoft Azure as it is named right now, as our cloud platform, public cloud platform, Windows 8 and Windows Phone 8. Just as a little disclaimer, and some of you might have noticed it already, when we talk about hybrid cloud, it's similar to many other terms in the industry. Everyone talks about it, but everyone has a slightly different understanding. What I've learned is that many people, when we talk about hybrid cloud, think about moving VMs between on-premises and the cloud using System Center, Virtual Machine Manager, and things like that. That's not the focus of this session. We're going to stick mostly to platform services for implementing hybrid cloud solutions like service bus messaging, service bus relay, data sync, and then we also touch a little bit on infrastructure through Azure VNet and things like that. If you expected System Center, I think there is still the chance to look for maybe another session that touches on System Center or things like that, or the Azure Pack. Okay, that said, we're going to directly jump into what I've prepared for you in 4 sections. Section number 1, I would like to put some context on what we are talking about when we talk hybrid cloud. So what is it? Why do we think it's a good idea? And what are the technology options that we have available? Section 2 digs into a couple of scenarios that I simplified from real-world projects to be able to bake it into a demo that I can provide to you through CodePlex after the event so that you can play around with it. So I have an end-to-end sample that I would like, or that I will publish on CodePlex, that covers those scenarios, and those scenarios are basically inherited or are simplified versions of things that we have implemented with partners out there. So it's not just plain theory, it's something that is related to practice. Then there are a couple of cross-cutting concerns with hybrid cloud computing that are important independent of which specific technology approach you're going to use to implement a hybrid cloud solution. And then the 4th section is the summary and leave you up into the wild in San Francisco. Okay, so let's get started with the first section and do a little bit of smart talking around hybrid cloud computing. So what are we talking about essentially when we talk about hybrid? So, well, think of the following scenario. You have your own data center, your private cloud, and you run applications there in your own infrastructure. And then there is the public cloud, and you want to make use of it. But you cannot put all and everything that you have on-premise into the public cloud. So you need to run your solution across both clouds, the public cloud and the private cloud. And that's exactly what I talk about when I talk about hybrid cloud. And when you look at this picture, of course, there are external clients as well. When you look at this picture, there are different ways of integrating those two worlds, integrating the pieces and assets that you run in your own data center with the pieces and assets that you run in the public cloud. And that's not just virtual network, VPN, and things like that, obviously, since I talk about platform services. So when you look at how we could integrate those two worlds, then there is the obvious way. We could integrate those two worlds through the same means as external clients are accessing our solutions, like through public HTTP load-balanced endpoints in Microsoft Azure, for example. That's the most obvious way to integrate those two worlds together. The second most obvious way, of course, is the infrastructure-driven approach. And since I want to give you a broad overview across all the options that you have and their advantages and disadvantages, we cannot ignore it. We just need to look at it. So that would be then building up a tunnel between those two networks that you run in the public cloud and in the private cloud through VPN in different flavors to be able, let's say, for example, to allow clients to manage VMs that are running in that data center. That's, of course, another option. And then, in addition to that, we have two additional flavors of options, I'd say, that we can make use of. One of that would be to synchronize data. Let's say you want to keep some master data on premise and you want to make that partially or completely available in the public cloud, then you can synchronize databases across premises to enable a hybrid cloud scenario. And finally, and last but not least, the service-oriented guys in the audience would say, yeah, that's all nice, but that's all too tightly coupled. I want to have it in a more loosely coupled way. SOAP, web services, web APIs, or maybe even async messaging. And that's kind of, in my mind, a more service-oriented way of implementing hybrid cloud through, that means of communication at the end of the day. Okay, so these are the different options. So if you summarize that, in my opinion, the general approaches that we have, in summary, for implementing solutions, implementing and designing solutions that run partially on-premise and partially in the public cloud are service-oriented approaches, where you expose web services that you run on-premises and make it available to the cloud, and of course, the other way around, but that's not the really hard challenge. Then we have messaging-oriented approaches where you use async queuing mechanisms to implement some sort of integration between the premises. We have data-driven approaches, which are more or less data sync oriented things. Then we have the infrastructure-based approaches. And one aspect that I did not cover in my graphic before are technology-specific approaches. Like, for example, when you think about HPC, and the Microsoft HPC pack for Azure. There you could implement topologies such as running the head node on-premise and running the worker nodes in the public cloud, or running a mixture of worker nodes in the HPC scenario in the public cloud and in your own data center, and the head node either in one or the other data center. Or, for example, who of you is using NoSQL databases such as Cassandra or MongoDB? So, not that much, but they have also mechanisms for implementing, like, for example, setting up rings across data centers, and that's also something that you can use for implementing hybrid cloud scenarios just for specific use cases like high availability. So these are more or less technology-specific approaches. I have summarized the most important one of those that we have available on Azure as a platform in that table for your reference. You don't need to read that now. You get the slides for your download. So I would rather dig into the next sections, which one is why should we do that all? And then the other one is dig into the concrete practical scenarios with code samples. Okay, so when we look at all of this, one thing is sure. Hybrid cloud does not make things easier. It just opens up additional options for cases where you might think the public cloud is not an option for you. But if you decide to use public cloud for whatever reason, for example, because you have pieces in your application that can really benefit from the characteristics of the public cloud, like the dynamic scalability, pay per use, and things like that. Then hybrid cloud gives you the option to adopt the public cloud, although you might not be able to move all and everything out into the public cloud and need to keep parts of that on-premise. That said, that is also the reason and motivation for public cloud, for hybrid cloud-based solutions, to make use of best of both worlds. But One thing is for sure, it doesn't make things easier. You need to take a couple of things into consideration, like latency between your data centers. Since you run things across two data centers, you need to make sure that you deal with high availability on both sides, and so on and so forth. So what I think is very important, apart from understanding the different technologies that enable you to implement hybrid solutions, is to also understand specific usage scenarios for which they are good for and for which they are not so good for. And I try to deliver that message as part of this presentation by giving you a couple of examples from the real world that should inspire you a little bit. I can't cover everything end-to-end in 50 minutes. They know that I'm usually running over time. I won't today. So they configured the clock 10 minutes shorter than actually the session time is. Okay. So let's dig into a couple of those demo scenarios and get a little bit more technical and freaky geeky. Okay. So before we dig into it, what I've prepared, as promised, is we keep the ink, is a little sample application that is based on a real-world scenario, but of course in a slightly simplified way. So that was when I did the rehearsal in front of my wife and my child. You see, they really like hybrid cloud. So what I've prepared is a little simplified HR web application that is based on that is not the web application. That is based on a scenario from an ISV that I've been working with in Switzerland, who is an internationally acting ISV in the HR space. So they are building HR-based solutions for performance and incentive management. And that's maybe one of the most comprehensive hybrid solutions that I've been working with so far, and most of the demos and scenarios that I'm showing are very simplified versions of what we have done there. So when you look at that web application, it has some data about departments in a company, and it has some employees, some data about those employees, like we have a monthly salary, and we have a nice little social security number. Whichever country takes social security numbers like this. Looks very strange, but anyway, it is like what it is. Then we have performance ratings. Look at me in person. That is the last performance rating I got, so I must have been really cryptic good. Well, I don't understand the rating. It doesn't matter. So that is essentially the web application. Now think about this application as a multi-tenant application that you want to offer to a large number of large-scale enterprises, like telcos, banking and insurance companies and things like that, that have several hundreds or even thousands of employees, and you are doing the performance ratings and their bonus payout management of those employees in that application for all of those customers. Definitely, that web application could benefit from the elasticity and pay-per-use characteristics and the scalability of the public cloud. Like, for example, dynamically reducing the number of instances for a region during night hours and pushing them automatically up again during daytime hours and things like that. Or increasing the number of instances during month-end cycles, because most obviously there we're gonna have some more performance ratings between employees and managers. But on the other hand, when I look at what happened in the banking industries and managers with their bonuses, some of those companies might not be happy to have that information somewhere in the public cloud in an unprotected fashion. And that's exactly what we see here with my performance rating. That's not clear text, that's encrypted. And they would like to keep the control of that data on premises. And this is exactly a hybrid scenario that I want to talk about. And there are some other things connected to it, like When we go to the homepage, we see that stockbrokers, in that case Fidelity and Smith Barney, are involved for bonus stock-based payouts. So we need to have an integration path with them, and that's what we're going to look at as well in that scenario. And we're going to apply different technologies and services that Microsoft Azure offers to implement such hybrid solutions. So that is the scenario demo that we're going to work with and that we're going to jump in to get a little bit more concrete on implementing a hybrid cloud solution. So the first thing that I mentioned in that application was, and let's do some fancy drawings again, that we have this Cloud HR web application, Cloud HR web, and that can benefit from dynamic instance scaling that uses Azure SQL database, which is highly available, to store some data about the departments and the employees, but we know that there is some critical information, some sensitive information in it that some people or some organizations don't want to leave unprotected in the cloud. So what we built and designed with them is a little service that runs on-premise. So let's pick, which color do we pick? That runs on-premise, that is a crypto service. And that crypto service holds a database of keys, public-private key pairs, essentially, that we use for encryption and decryption. The public keys need to be provided to the HR application to be able to encrypt the data in the public cloud, but whenever it comes to decryption, that needs to happen on premises. Now, you could say, well, it's still then the HR application that delivers the content to the browser. And then from a practical means, when you look at most of the certifications like HIPAA and so on and so forth, they don't have a problem with sensitive data in the cloud as long as it is not persisted. So as long as we don't persist the sensitive data and as long as it's only in memory for a short period of time, we are fine. So what we actually do is we store the data encrypted in the cloud, and whenever we need to deliver it to the browser, we go to that crypto service and decrypt the data and deliver it to the browser, and then it's again gone, and we only have it encrypted in the cloud. So now, when you think about this again as a product or a service that an ISV wants to offer to the enterprise, a company like Orange or whatever, when you start discussions around, we have this crypto service, you just need to open up a port on your firewall. Oh, yeah, you just need to open up a port on the firewall. Let's meet next year again. So don't open up the port on the firewall. On the other hand, we need to have some sort of request-reply-based communication here. Because if the data needs to be delivered to the end user, we need to encrypt it immediately. We can't wait for another message arriving somewhere on a message queue. So one mechanism that we applied for implementing that specific solution is making use of a component that is called Service Bus Relay in Windows Azure that allows you to make services that do run on-premise available to other parties through a private service registry that runs in the cloud. When I explain Service Bus to newbies, I usually say, think of it like TeamViewer for web services. Who knows TeamViewer? Okay, not so many people, so it might not be the best explanation. So TeamViewer is a remote desktop solution, and it actually works in a way where you install a little agent on your machine that connects to the TeamViewer service, and then on any other machine where you also install that agent and sign in with your account, it connects to TeamViewer, and it makes your machines available that have the agent running on the other side. Service Bus is pretty much the same, just for web services. So you have a little agent running on premises that connects to Service Bus and remains that connection open. And then you have your cloud-based application that connects to Service Bus as well whenever it wants to call that service, and service bus bridges to the already opened connection. And since the on-premise software only makes connectivity from inside out and does not receive any connectivity from outside in, we don't need to configure, in most cases, something at all on firewalls. So it's a little bit easier to sell for an ISV. So now from a security perspective, somebody could say, wow, you can bypass my firewall? Pooh, that's dangerous. But I think that this method is at least as secure as opening up a firewall port and doing some IP address restriction stuff. Because the way it works is that this guy here needs to authenticate against service bus. This guy here needs to authenticate against service bus. And service bus, since it is a protocol-based relay service, also is able to pass through the authentication that your service needs over there. So you have 3 times authentication in the place with most probably different types of credentials. Okay, so that's this scenario, and as promised, I have built that for you. I was sitting in the plane like this when I was coding this. Fortunately, the flights are very long, and my back feels really strange now. But anyway, I have built it. So, and I hope I can publish it. Fun story with the publishing stuff later. So, what I have done here is that website that I debugged locally, I have running it in Windows Azure as a website. No, not this one. That's for another conference. Being part of too many conferences at the moment. So MSZ built hybrid demo. So when I open that up in another browser, HTTPS, MSZ built hybrid demo, .azurewebsites.net. It asks me for credentials. I secured that one using Windows Azure AD, one at mszbis demos.onmicrosoft.com, and then we have thousands of passwords that I need to remember, thanks to KeePass and eKey. So now we're going to log in, and now we're going to see that thing running in the cloud with different data because it stores its data in the public cloud. And here we have our employees, and here we have the encrypted data. And when I go to details, it tries to decrypt the data. So let's do that. So whoops. It says, oh my God, an error occurred. There was no endpoint listening. So that was, of course, prepared. So what it tries to do is it calls to service bus. It calls to service bus into a registry, looks if there is a service registered in my private namespace against which I've authenticated and which is listening. And unfortunately, there is no listening, no service listening. So what I need to do is I need to start up my on-premise service here. And that's exactly, although Service Bus Relay is easy to use, that's the thing that you have to take care of. You need to make sure that your on-premise service runs appropriately. And if it doesn't run, you need to have a failover strategy, such as running the service a second time on another node, in another data center, on premises, and things like that. So let's start debugging my crypto service console app. So I need to say console app because I have a colleague sitting in here who always chases me when I say console app, so I say console app. So here is my on-premise encryption service, and now when I go back to the other browser, I'm getting confused by too many browsers, and hit Control F5 to refresh, what we're gonna see is in the console, we see messages that I'm retrieving a key that is used for decryption. I decrypt the data and I pass the decrypted data back to my ASP.NET MVC app to kind of be able to use it there. So fortunately, one of the advantages of Service Bus Relay for .cf developers is that it is fairly easy to use. So all you need is in the Windows Azure SDK that Microsoft.ServiceBus assembly, and then for the different protocol bindings, what you have here is you have different binding and behavior implementations. So my console application actually supports running with and without service bus. When it runs without service bus, it just builds up a WCF listener that runs on localhost. When it runs with service bus, it uses not basic HTTP binding. I should have used WS HTTP binding, but configuring that in the plane was a little bit too hard. So I stick to the more simple thing. Basic HTTP relay binding, and that is the one that connects up to service bus. Now, how does it authenticate? Well, the answer is a transport client behavior where you need to pass in credentials that you have configured before so that service bus accepts the connection by the application. And the client does the same thing on the other side. So that's service bus relay. And as you have seen, the caveat with service bus relay is that when it's not running on premises, it's going to fail. So for a different scenario where we might need a higher level of reliability, we might need to have a different solution. And that's exactly the next scenario. Message-driven integration across premises. So in that scenario that we have been talking or discussing about with that ISV, the scenario which they had is they had bonus payouts. And bonus payouts can be cash and can be stock in many companies. When it's cash, it's handled by the internal financial services department or by a contractor who is doing that. When it's stock, it's typically handled by someone who has the connections to the brokers so that the stock transaction runs. And for payout stuff, people are very sensitive. So if that fails, it gets kind of critical. Because, yeah, I don't know why. So in that scenario, we would need to do a different approach. Like we, again, have our funny HR application in here, HR Web, that uses Azure SQL Database. And on-premise, we would have, again, some sort of agent. So one for the financial services department agent, who talks to the local, for example, SAP system, and then other ones for the broker agent, so for the brokers, agents as well. I have another ISV, for example, in Switzerland again, many Swiss ISVs, I've been doing a lot there over the course of the past 2.5 years, who are using that kind of principle for other scenarios, like integrating on-premise CRM systems with their CRM extensions which they run in the cloud. And they provide these agents as a kind of a click once package. So whenever a new tenant is onboarded, that is a completely self-registration kind of process. And at the end of the process, when the customer purchased the product, they point them to a link, hey, download the agent there and run the installer on your system so that the agent can connect to your tenant and synchronize the data in a message-driven way. And we could think of it in this scenario in a similar way. This time, what we actually here have done is we implemented service bus topics, which is a mechanism for publish, subscribe eventing system. And we have one topic in that case, whoops. We have one topic for the brokers where we push out messages for broker payments, and we have another topic for salary payments that are queried by the financial services thing. Since on the right-hand side, it's a one-to-one relationship, I could have used ordinary queues. Yeah? And on the other side, we have a one-to-many relationship potentially. Yeah? So here, we're going to have two subscribers which subscribe to messages based on specific properties. And what we used here is topics with subscriptions plus filters. And in my demo app, I've implemented a very simple filter based on the broker name. Yeah? So the HR app sends the messages to the topics, and then we have multiple subscribers, and they receive it. And even if the subscribers are not up and running, the messages get persisted. Which brings me to an important point that I did not implement in my demo, but you would need to consider it. If the data is sensitive, you should encrypt the content of the message as well and then decrypt it on premise. But that works very similar as the encryption-decryption approach that I've implemented before with the service bus relay. So let's look at this in action. When you look at my where is it? My little web app. So they are already celebrating the party, the pre-attendee party. So when you look at my ASP.NET MVC app, it has a payout method, which is called when you click a payout button or link, Shift-Alt-Enter, that sends the messages. So what I do first is I collect the employee salary information. That's database stuff. That's boring. And then I compose messages, 2 types of messages, one stock transaction message and one salary and bonus message, and I send those. The salary and bonus message is a pretty simple send operation where I use the service bus APIs to create the topic client. I could have used the queue actually since we have a one-to-one relationship, and I just sent the message along the lines. For the broker, when we look there, for the broker stuff, with the stock messages here, I have an additional property in the message that I use for message filtering, which is the broker name. And when we look at the service bus namespace, how it is configured in Windows Azure, then we have 3 subscriptions here. Let's zoom in a little bit here. We have 3 subscriptions, one for our financial services department, for the broker messages topic, one for Smith Barney, and one for Fidelity, and they have rules bound to it, which says, hey, that subscription, broker subscription Fidelity, is reserved for Fidelity, and it should only pick up messages with the broker name Fidelity. And you can actually secure that by adding additional credentials into the Service Bus Access Control namespace in the Azure Management Portal and tell him that on this subscription, only somebody with this connection string A can connect, while on the subscription Smith Barney, only somebody with the subscription B can connect. And that way, we can make sure that only messages are delivered to recipient that should deliver those get those messages. So let's give that a try. I did sign out from my public cloud stuff already, so it doesn't matter. Let's say MSZ hybrid, and then I need my password again. Copy password. User1 at mszbizdemos.onmicrosoft.com. So they could have selected a shorter domain name for demos. So the demo domain namespace. So I can start sending messages, and since everything happens asynchronously, I can say I want to have the payout for Chief Executive Cortana, since she was in the keynote. Oh, what's there? Payout. Ah, that's interesting. Ah! Ha 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 ha. I need my decryption service because I decrypt the salary data and the rating data in the bonus ratings, and then I send it. Start new instance. So, well, the program got a little bit more complex, and that's exactly the story with the publication. I want to publish it, payout. I just do one payout, and then I start the applications that are actually receiving the payout. And then I talk about the story with the publication of the demo. So the encryption stuff. Then I have here in the demo 2 other projects. One is the adapter for the financial services department. I can start a new instance of that. And then I have another application, stock transaction receiver. That is the adapter that the stockbroker needs to install. And I'm starting it 2 times. One for Fidelity and one for Smith Barney. And now I have a window chaos here. So Fidelity, enter, and Smith Barney. And he received one already. That is the one that I sent when I hit payout before. And that's the big difference between service bus relay and that messaging-based approach. Of course, Smith Barney did not receive it. And then he receives the salary message and the stock message. And I thought, because the financial services department for the bookkeeping should keep track of both messages. So when I go back to my application and do the payout for the developer dev chief payout, I should see, again, the department is managed by, I don't know, is that Smith Barney or, doesn't matter, one of the brokers. And again, here the salary. One last thing, that is a neat thing for really troubleshooting, debugging stuff with Service Bus. We experienced it with another open source project that I was working on. When I do a same payout for one of those guys that I did where I did the payout before, you'll see payout that we only receive the salary messages anymore, but we don't receive any stock messages in yellow anymore. And that is because for the stock messages, I have enabled in Service Bus in the topic the duplicate message detection, which happens based on the message ID property, whereas for the salary one, I did not enable it because I want to have happy employees. So that is another approach for implementing a hybrid cloud solution. We're going to close up that console applications, making my colleague happy. So there are a couple of advantages and disadvantages, which you can read afterwards. But if I want to name one important advantage of these approaches, then it is the one that you can control the semantics of when and how somebody is allowed to connect to your on-premises in your application logic and application code. That is something that is much harder to implement with infrastructure-driven approaches, where you would need to dynamically script firewall rules and IP blocks and things like that. So that is one of the biggest advantages that I see in those approaches. Then we have data-driven approaches through, for example, Azure SQL Data Sync, where you just synchronize databases that run on-premise with databases that run in the cloud. There are two approaches for doing that. One is data sync, which is unfortunately in preview for a very long period of time already. But there is another option that is released and that is supported that can be handy for database developers and report builders, and that's linked servers. So you can add an Azure SQL database, for example, as a linked server in your on-premises SQL server to do fan-out queries across premises, and also, for example, you could apply triggers on your on-premises databases that automatically insert data into the databases in the cloud, and that's fully supported and released. I'm not going to dig deep into those because data sync essentially is a configuration wizard that you run through in the portal, and then you need to install an agent, similar to what I did with Service Bus, and you configure that. That's fairly straightforward, and also configuring the linked server is fairly straightforward. So the advantage of that is that you don't need to develop a lot, so you don't need to write code and change things in your application. The disadvantage, nevertheless, I think, is that it lacks a little bit in terms of flexibility, because the synchronization mechanisms, independent of which one you select, usually means that you will run into some limitations with regards to data types and identity columns and issues like that. And that, to be honest, in practical terms, I have never seen a large-scale solution that did sync at the data level, and that was another reason why I don't do a demo for that. So the large-scale solutions apply message-driven, Service Bus relay, or infrastructure-based approaches. And that is the last approach that I want to talk about, infrastructure-based approach, but not with regards to System Center and things like that, but with regards to Azure Virtual Network. So Azure Virtual Network gives you an opportunity to create a private network with its own IP range in the public cloud for your virtual machine and platform services, so that they can communicate through a private channel in the public cloud together with each other. But you also can use it to create a site-to-site or point-to-site VPN connection to your own data center through a VPN router such as Cisco, Juniper, and things like that, or Windows Server 2012 routing services. And again, coming back to the HR scenario, that ISV had the following challenge. They wanted to run all and everything in platform as a service because there it's automatically managed and they don't need to take care about the operations management. But some of their customers wanted to run analytics on top of their databases. And they wanted to do that with SQL Server analysis services. So there is no SQL Server analysis services in Azure today as a platform service. The only fallback is virtual machines to run SQL Server in VMs, to run reporting services in VMs, and to run ETL with integration services in VMs. And the way how we have designed that, since the customers and the customer tenants wanted to have full control on those OLAP cubes and customize them, is that we said, okay, we're going to create one VNet per tenant, so every customer gets its own VNet. We talked to Azure SQL Database, also one database per customer strategy, through linked servers into that VMs that also run either in the cloud or on premises. Some customers prefer one, some others the other solution. And then, if the VMs run in the cloud, we create site-to-site VPN connections so that they can manage those VMs. And there, it's a pure infrastructure play. You don't need to develop anything apart from maybe PowerShell scripts to automate that deployment. And it essentially should just work. Another scenario, and that's site-to-site. Another scenario that I really find super cool and that I've seen especially with small to medium-sized software vendors in Europe is to outsource your own infrastructure. Like most of the small to medium-sized ISVs, they don't want to take care about managing their own internal servers for whatever SVN, the bug tracking tool, or the time tracing tool. Just get rid of it, outsource it. Another thing is managing servers for DevOps, dev test debugging stuff. Yeah? And here, point-to-site VPN really comes in handy. For example, I have a partner in the DACH region who got rid of all of his servers, and the developers are just equipped with really strong notebooks, big bricks, and they use point-to-site connectivity into a virtual network in Azure where they run their servers. And to reflect that back to my demo scenario, that is the only part that I cannot hand over to you. What I have prepared for you is the following scenario, and that he liked as well. Let's think about this solution again that we have here. It makes use of service bus events, topics, and relay. And most often, an ISV has that question. Yeah, I want to run it in the cloud, but there is this one customer, he wants me to install it on premises. Oh, damn, so I need to have an environment where I can test whether it really works without Azure. And when it comes to components like Service Bus, there is something available that allows you to run a subset of the services that we have in the public cloud, also in your own private cloud through the Azure Pack. So I talked about at the beginning that we're not going to cover Azure Pack in detail, but what I did is, from a scenario perspective, for our demo application, we want to test whether it runs in the Azure Pack. So what I did is I fired up a couple of VMs in Azure yesterday afternoon in a virtual network. So that virtual network is down here, built hybrid demo net. And in that virtual network, you have 3 machines. That's the minimum setup that you require for an Azure Pack Express test installation. A SQL Server, a domain controller, and Build SB runs Azure Pack with the Service Bus for Windows Server. So what we're going to do is, and I created a point-to-site connectivity. So under Configure, down there, you'll see point-to-site connectivity. I activated that. After that, you can create the gateway, which I've done already, and download a VPN client here. I've installed that VPN client, and that VPN client gives me connection to an Azure tenant that I run in that server. Oh, I need to connect. So connect, continue. So now it connected, Control F5. Yeah, certificate validations, continue. We all love security. Yes, continue. So now MSZ hybrid build Mario SZP, and then we have another password. We all love passwords. So I hope I picked the right one. So that's the administrative UI for the Azure Pack. And I open up in parallel a second website, which is the Azure Pack tenant that I created. So it's fairly slow, but it's coming. Continue. And I run Service Bus there. And what I can do now is, after I have logged in and queried the connection string, MSZ hybrid build.local, paste the password, so I have a user for my developers in that Azure tenant. So that's how it looks like when you have the Windows Azure Pack. Here I have registered a Service Bus Cloud. That Service Bus Cloud runs on that machine here, as you can see. And that Service Bus Cloud is made available to users on the other side. It's gonna be a point in time, whatever. So Service Bus, dev namespace. Here we have topics and queues, but we don't have anything in here. So that's my Service Bus that runs on premises. I can connect or copy the connection information. Looks like Windows Azure in the public cloud. And then I go back to my application and try my little beast here, the HR adapter, and say I want to connect to my on-premise Service Bus instead of this. So now it's connecting to servicebus.windows.net. Paste, and since I'm point-to-site connected, that's very neat, and that's exactly the point. Yeah? So I have my dev workstation here. I have point-to-site. I just use it, and I don't need to maintain another bunch of hardware racks that run the Windows Azure Pack. And if you do a serious deployment, you need at least 8 cores. So that's easier to run up there as opposed to here on premises. So now we're going to test if my solution works, and we're going to have a surprise. It tries to connect, and it runs into an exception, and it tells me, and that's a nice little gimmick, it tells me the API version in the query string is not supported. Oh my God, I have used Service Bus 2.2 or higher. I was too eager with installing the latest NuGet packages. So let's see, F4. Yeah, it's indeed 2.2. So I need to pull that out and say, package manager console. So, and say install package Windows Azure.ServiceBus version 2.1.0 project. Now I need to, project is HR Finance Adapter.salary payment. I have taken too long project names. For the demo, it would have been better if it would have called demo HR1 or something like this. So now it installs Service Bus 2.1, and that one is compatible with the Azure Pack, so we have successfully tested that. Debug, start new instance. We have success, strike. And now we have it on premises. Where is it? Topics. Now we have all the topics there, and we can do the stuff there. So I think that's a really, really cool scenario for point-to-site VPN and things like that. Okie doke, so let's switch gears for the last minutes so that's infrastructure-driven approaches. So let's switch gears and talk a little bit about cross-cutting concerns that you need to take care of. That's identity management, authentication, and single sign-on, connectivity, and unified operations management. In case of identity management, I just briefly walk through that since there are other sessions that are covering those topics in specific at Build. So either watch the recordings, because today there have been sessions about Windows Azure Active Directory from Vittorio, and I think tomorrow there is a session on the topic that I'm talking about in a minute. and that's Active Directory. Windows Azure Active Directory is the service in our cloud that allows you to implement identity lifecycle management and single sign-on across premises based on open standards such as WS Federation, SAML protocol, or OAuth. And if you need data from your on-premises directory to be queried also by your application in the cloud, you even can set up directory sync. So now the nice thing here, and that's one of the key advantages that I see in that world, with that is Windows Azure AD by its nature is multi-tenant. So now if you are an ISV who needs to integrate with many corporations, usually what you do is you ask those corporations to set up a SAML server or a security token service, and then you set up a trust relationship. Now think of it, what that means for an ISV who runs a service. The first customer, first trust relationship with ADFS or Shibboleth or whatsoever. Second customer, second trust relationship. Third customer, and so on and so forth. And you will have to manage, maintain, and configure all of that in your application. When you put Windows Azure AD in between, your application has a single trust relationship to your Windows Azure Active Directory, which runs the tenants and where you run the directory sync, and Windows Azure AD hides the trust relationships to all the other tenants and takes care of the single sign-on. No big .cf web.config with hundreds of system.identity model configuration sections that you will lose control of if the number of customers is growing. Azure AD is doing that for you. And that's, for me, one of the key advantages. Then we have connectivity as a point. I mean, when we look at the samples that I have been showing to you, then we were always going through the public internet, which means that we can run into issues with latency and things like that. And I did yesterday in the hotel, the internet connection wasn't that good. So if you really, really need fast and stable internet connectivity, ExpressRoute is the internet. Connectivity to Azure ExpressRoute is the answer, which is some sort of direct connectivity through ISP partners that we are working with into our Azure data centers based on the backplane peering networking infrastructure. In specific, we are working with Equinix Level 3 and AT&T. As of today, the service is only available in US in those two locations to connect to backplanes, but that's going to be expanded, and I think tomorrow there is a session about ExpressRoute that talks 60 minutes only about this. And then finally, there is a unified operations management, and that's all what I have to say about System Center. Microsoft's way of unified operations management across public and private cloud is System Center. But it makes essentially, and that's the side message of that, it makes essentially just use through its management packs of the Windows Azure Service Management and Monitoring API, where also third-party solutions or your own custom solution can grab all the monitoring data through an HTTP REST API. And in the meantime, we also have .NET libraries available through NuGet that you can use to write your own kind of .NET-based tools if you want. But if you want a ready-to-use kind of solution, then our answer is System Center. Okay, so these are the cross-cutting concerns. So let's come to an end, and let's do a point-in-time landing for the session. So we talked about hybrid cloud, which means you use the best of both worlds, run parts of your solution on premise because you are not allowed or you cannot move them into the public cloud, but where you can benefit from the characteristics of the public cloud, move it to the public cloud, and use integration points if it's possible for you. Like if service bus messaging or service bus relay or data sync or VNet as options that we have available are possible and viable solutions for you and for your scenario, then don't block yourself from getting into the public cloud and using the benefits just because of one little piece in your application that might not be allowed or able to be put into the public cloud. So we have built a little scenario based on an HR application, which is based on a real-world scenario, which is a little bit more complex, of course, but otherwise I would not have been able to give you the application, which brings me to a point. I'm going to publish that demo on Codeplex, but there is a little caveat with it. It will take some time since I have counted the number of lines of code of that application that I've built, and it's currently at 1,200 lines of code without the headers for the open source license, for the Apache 2 license, and that is counted as well as lines of code. So I need to submit that application to our legal department so that they can look whether I'm not violating any patents and things like that. And if they give me the approval, then I can publish it. And knowing it from other projects, it can take a while whenever legal department comes in place. But I'll try to cut some lines of code and maybe then I can publish it faster. But I will publish it, that's my promise. Just look at my blog, monitor my blog that's blog.mszcool.com. So, yeah, that's my blog. And the first posting is about Java, put it away. So, but it's Java on Azure, so it's something good. Anyway, just monitor my blog. As soon as I've published it, I will post it there. With that, all I have to say is thank you for your attention and for your interest in the session. I hope you did like it and have taken at least one or the other thing away from it. It was a pleasure to me, my first time at Build, and if you did like it, maybe next year again. And if you give feedback, feedback is important, of course, but if you give feedback, the most valuable feedback, to be honest, is not ticking the boxes. The most valuable feedback is written feedback, so I would be eager to get your written feedback. So thanks a lot, and with that, have a nice evening.